Hey y'all, Data Guy here. And today I have a video for you where I want to explore how you can design a stable and efficient microservices architecture for your business or your use case or whatever kind of application you might be building. Microservices architectures have gained a ton of popularity, especially in the past decade, as you really have enabled them to be possible with the rise of cloud, scalable computing systems, and so they're now a very favorite approach for most applications for designing scalable, maintainable, and efficient software systems. And you can kind of see an example here where this architectural style breaks down a monolithic application into a collection of smaller, loosely coupled, and independently deployable services, where each service is designed to handle a very specific business function, and then it communicates with the other services through well-defined APIs. So what I'm going to do in this video is, just kind of give you the basics of how microservices architectures work, typical services included, the pros and cons, provide some guidance on setting up your own microservices-driven system, and then also give you some real-world examples of how companies are implementing microservices today, so you can kind of draw some inspiration from them. So without further ado, let's get into it. So at its core, microservices architectures work by decomposing an application into a set of different services that can be developed, deployed, and then scaled independently. So each microservice, and I have an example up here, corresponds to a particular business function or domain. So you have things like user authentication, backend storage, payment processing, inventory management, queue management. And these services all communicate over a network that either uses lightweight protocols like HTTP or HTTPS or messaging queues, and that's what you see with RabbitMQ here. This decoupled nature allows development teams to work on different services simultaneously without actually interfering with each other, which fosters a much more agile and responsive development process. And now a typical microservices architecture is going to contain a pretty wide variety of services, but some commonly included services are the API gateway, which will act as an endpoint, and you can kind of see that here, or on the left side of this diagram, where that will serve as your entry point for client requests, and then route those to client requests to appropriate servers and appropriate services. So authentication and authorization services are typically next, and those will handle user identity, access control, and then go into business logic services. So in here, you actually have service discovery and discovery cluster, which is serving recommendations for Netflix. In this example, Netflix, this is showing, hey, how Netflix will take your user input, you then serve it into its discovery cluster to serve you then the movies that it's discovered based on your search. And so this is kind of showing that example where you have various different services, a lot of here Dockerized, especially because many times in microservices architectures you're going to be using Dockerized sub-applications, because then you can kind of isolate the function of a single application even if it's something you've developed, these are referred to as business logic services, and they are services that encapsulate core application functionalities. Then there are also database services responsible for data storage and retrieval. And then there's also monitoring and logging services that track the health and performance of the actual microservices environment. You can see that here in this data collector as well. So making sure that you're maintaining and monitoring systems to track the health and performance of a microservices architecture is really critical to making sure it remains efficient. So now, what are some of the reasons that you might want to actually build a microservices environment? Well, the advantages of microservices architectures are pretty significant. And the main one, in my eyes, is improved scalability. Instead of having a massive bloated application that you just need to keep tacking on additional compute to, growing until it's just an absolute behemoth, with microservices, each microservice can be scaled independently based on the specific demand for that microservice. You don't have to scale your entire system up. You can just scale the specific parts that actually need it, which optimizes resource utilization and then has the downstream effect of also enhancing performance. Microservices also promote greater development agility and speed versus monolithic architectures. With monolithic architectures, if you want to push any change, it can pretty much only be done one at a time. Development on a service has to really consider all the other components of that monolithic architecture, versus with microservices, each service is loosely coupled. So you can have a development team that works on the authentication service, another development team that works on the delivery service or database service, all completely independently, And that means they can adopt a continuous delivery approach, deploying updates and new features without worrying about affecting the entire system. Additionally, microservices architecture enhances fault isolation. Again, with a monolithic architecture, a failure in any part of that system can cause the entire monolithic architecture to crash. Versus in a microservices architecture, you have fault isolation because a failure in one system does not cascade to the others because they're completely separate. They're running on different hardware, running on different software, and that will improve the overall stability and resilience of your system. So unfortunately, there are some disadvantages of microservices architectures. It's not without its challenges. And one of the primary drawbacks is really the complexity involved in managing a distributed system. The advantage of a monolithic architecture is and the drawback is you just have a single place where you're managing everything. When you have a distributed system, you have many different systems that you need to monitor and manage and tie together through APIs and networking. And so you need to almost have a kind of control layer above all of your different systems that can monitor and manage them effectively. And so this means there is a big need within microservices architectures for service orchestration, a good network communication platform, and then also establishing strong data consistency standards across your services. And that also introduces a pretty significant overhead across just the base systems needed to run your application. You also need to think about the cost and both monetary value and also time and energy in maintaining kind of the monitoring and orchestration layer. And then compounding this as well, ensuring robust security across many different services that might have different authentication methods, different ways of saving and preserving information can be pretty difficult. And so maintaining a comprehensive and monitoring and logging stack are critical challenges, but they can also be quite difficult with microservices architectures. And then finally, kind of a logical one, but the increased number of services also leads to higher operational costs, and then will require more sophisticated infrastructure management tools like Terraform. I guess Terraform's almost ancient at this point, but infrastructure management tools in general should be utilized in managing these types of architectures. So now that you have an idea of the pros and cons, I want to talk about how you can set up your own microservices driven architecture in a way that maximizes the benefits and minimizes the downsides. And the first thing to do is start by identifying the key business functions that can be modularized into individual services. So this means conducting a thorough analysis of your application's domain, so you delineate the boundaries of, hey, what are the authentication services we're using? What are the database services we're using? And then define them as separate entities, separate units that will be developed independently. And the increased number of services here also leads to higher operational costs and requires sophisticated infrastructure management tools. So make sure you are thinking about the fact that you will need to do that. Additionally, design protocol or APIs, so application programming interfaces, for communication between those services. And then also make sure they're well defined and adhere to a standard set of protocols. So just think about, hey, how do I want my applications to interact with each other? If there's a login endpoint, make sure it's -login on all of your different APIs. And then implement an API gateway to manage client requests, and then also facilitate seamless routing to appropriate services. And that could be meaning things like implementing load balancing, round robin routing, to make sure that no individual service gets overwhelmed. The next thing you should be doing after you kind of develop this framework is choose the appropriate technologies and frameworks for building each of those services. And here you should consider factors like performance, scalability, and team expertise. So containerization technologies like Docker, coupled with orchestration tools like Kubernetes, are essential for managing deployment, scaling, and operation of microservices. Additionally, as I've mentioned before, you're going to want to make sure you incorporate robust monitoring and logging solutions from the outset to maintain visibility into your system's health and performance. So tools like Prometheus for monitoring and Elasticsearch, Logstash, Kibana Stack for logging are really popular choices in the microservices community. Then, everyone's favorite topic, security, is another critical aspect. And for that, you're going to want to make sure you're implementing strong authentication and authorization protocols, preferably through OAuth or JWT tokens, to ensure inter-service communication. And then also make sure you're regularly auditing your services for vulnerabilities and adopt a zero trust security model. Finally, This last thing here is embrace a DevOps culture within your organization to facilitate continuous integration and continuous deployment practices, which will help ensure that your microservices architecture remains agile, scalable, and resilient in the long haul. So now I wanted to wrap this video up with a couple real-world examples of how real-world companies use microservices. And a great example is Spotify. So Spotify uses microservices to support its entire music streaming service, and each microservice at Spotify is responsible for a specific function, such as playlist management, music recommendation, or user profiles. This architecture allows Spotify to scale individual services based on demand and then release new features without disrupting the entire system. For example, the music recommendation service can be updated and scaled independently from the user profile service, ensuring a seamless user experience even during peak usage times. And also, when Spotify rolls out new features, you might notice that they do it in small chunks of the world, and that's something that their microservices architecture allows them to do, make modifications to the service that is consumed by a certain region, but without affecting everyone globally. Another good example of a company that actually started with a monolithic architecture and transitioned to microservices is Walmart. So Walmart transitioned to a microservices architecture to modernize its e-commerce platform after its monolithic architecture would crash during peak times like Black Friday. So you can imagine people get pretty mad when there's downtime and really slow, buggy response times on one of the most popular shopping days of the year. And so Walmart was able to make this kind of huge shift and adopt microservices and then decompose its systems into smaller independent services responsible for specific functions like inventory management, order processing, customer service, and then fragment those even across different regions. You can see in this example you have a service handling Azure East, handling Azure West. You can scale up Azure West, the West Coast starts ordering a ton more without needing to scale the entire system. And this shift also allowed Walmart to scale services independently and improves fault tolerance and then enhance its overall system performance. And those are just two examples I wanted to show you of how big companies have designed efficient, stable microservices architectures. But I hope this video has really helped you developed a deeper understanding of how the benefits and challenges associated with this approach and help you decide if this is the right approach for your business. And if it is, hope you've gained some best practices on how you can actually enable and develop a microservices architecture to maximize those benefits and minimize those downsides. So hope you have a great rest of your day. Data Guy out.